So I've been learning something new lately, mathematics, and in particular how to prove things, and it's a great reminder of just how difficult, cognitively and emotionally, a significant learning journey can be. And so I got to thinking about how unusual this middle stage is between not knowing anything and essentially knowing everything you need to know about a topic. Now, at the beginning, you don't really have many misconceptions because you don't know how to do anything yet, and once you've essentially completed a piece of learning, you know more or less everything you need to know to solve the problems in that space. So you have a kind of sensical set of ideas. In the middle, you'll have this big bag of stuff that kind of doesn't make any sense. And the more you think about it, the less sense it makes. That's kind of part of the idea. But you need these ideas. They're not simply misconceptions. You need them to move on to the next stage. So I thought I'd make a video about it, and this is that video. We're going to start off looking at a little problem that I struggled with a couple of weeks ago. Then we're going to look at some theory and maybe we'll manage to draw some conclusions. My hope is that I, maybe also you, will come away with a better understanding of this middle stage and hopefully be better at getting through your own and my own learning journeys. Let's take a look. Here I am solving my third ever proof problem. If a is an odd integer, then a squared plus 3a plus 5 is also odd, and I've got to solve this using direct proof. I start off by writing the starting point, that's the formula for an odd number, and then I think over my approach. And we need to somehow transform that into this form. Well, we're going to have to square it, right? Or I guess we can probably write down our end form. Our end form is going to look like, how do we do that actually? We say, no, actually we're going to end up with, and after all that, I get to a squared plus 3a plus 5 equals 2c plus 1 to be my endpoint. Now I'm already kind of off to a bad start here, but here's where it really starts to go wrong. I start squaring a and work out what that is, but I'm not really sure what to do with it. Doesn't look great for us. We could divide everything by I guess we need to think about what c is going to be. What would c have to be for these to be equal? C would have to end up being something super weird. And then I just stare for a bit, not really sure what to do. Thinking about what C needs to be is kind of the right idea, but I'm not really sure how to go about it. I get some pointers from my ever supportive chat. I look at 3a and I, for some reason, try to factorize a squared plus 3a, but again, it sort of maybe could be helpful if I knew what I was doing, but I don't, so I, again, don't know what to do with them. Eventually, I summarize my position. I think I think the algebra part is okay. What I'm not quite getting is what I'm actually directing myself towards. I think that's what I'm missing at the moment. I'm sort of at the point where I'm like, okay, so, we could do any number of operations here, but I'm not exactly certain where I'm going. So how do you do it? Well, I can now show you because I know how to do it. This is like the fourth take I've tried of this because I keep messing it up. So it's all just writing down the wrong number, but I can do it. So we know that a is odd, so what that means is we can express it in terms of 2 times something plus 1, where that something is, oh, terrible symbol there, that something is an integer. That's what this Z stands for. It means a whole number, it can be a minus number, but it can't be a fraction or anything, or at least not a non-integer fraction. Then we take this and we substitute it in to this here. So we have 2b plus 1 squared plus 3 times 2b plus 1 plus 5. Then we just multiply this out, so we can say 4b squared plus b plus 1 plus 6b plus 3 plus 5. And then we collect the like terms, so we've got 4b squared plus 10b plus 9. So the question is then, what we need to prove is that this this a squared plus 3a plus 5, which we've just sort of re-expressed using this b value, we need to prove this is odd, and the way we can do that is if you can express it in terms of 2 times an integer plus 1, then it's odd. So let's see if we can do that. We can open our 2, and of course we can put this 2b squared here, multiply that by 2, you get 4b squared. then we can have, if I can do my plus right, then we can have 5b here. 2 times 5b will be 10b. And then we can't quite do this exactly, but that's fine. We can just put in 4 here. 2 times 4b, 8. And then we have the 1 left over, so we've got this 1 on the end. So what we've essentially said is that this formula here can be expressed like this, where this chunk in the middle, this thing 2 is times by, is an integer. We know it's an integer because it's just made of multiplications and additions of integers. And so now we've got something which, because it's able to be put in this form, we know it's an odd number. Of course, if you were going to prove this, then you'd need to put it in sentence form and stuff like that. But this is the core idea of how you prove this. So why couldn't I do it? Well, it was funny looking back at it because I couldn't quite remember what on earth I could be thinking. Like it really didn't make sense to me how I couldn't see what I was supposed to do. Like it really didn't make sense to me. But after thinking about it a bit, I think I have a reasonable idea what I was trying to do. So let me change my color here. I basically thought of proving things according to a kind of model of like morphing or transformation. So I was like, okay, so what you do with a proof is you take your thing that you're given, that's this thing, and then you encode it in algebra somehow. And then you look also at the thing you're supposed to prove that it is, and you put it in some sort of form. So we've got this as our endpoint here. And then your job really is to try to transform this thing here through a series of steps of some kind of algebra, I don't know, into this type of form here. And that's really the job. You can't just like take the thing you're supposed to have at the end and put it in at the start. That's like cheating. You can't do that. So I like to think of it a bit like, if you sort of had a shape at the start. I'm going to just do this. I'm not going to do this right now. I'm going to put it on the screen. You have a shape at the start and maybe you need to get it to a shape at the end. Maybe you like move around little bits of it so that eventually it ends up looking like the shape it's supposed to be. That's how proof is supposed to work, or at least that's how direct proof is supposed to work. At least that's how it seemed to me at the time. I actually just thought of another analogy for this, which is a bit like an anamorph. You start off with the human and you end up with the animal. That's how proof is supposed to work. But that's not how proof is supposed to work. So what is proof about? Well, I still don't know well enough to tell you in video form, so I'm not going to. It's something about working from the givens to the statement to be proved, but I'm still only really halfway there and I wouldn't want to mislead anyone. I'm kind of in that stage after you don't know anything, but before you have a reasonably complete understanding, a kind of middle stage, which is really what this video is about. One man who studied that middle stage a lot was Jean Piaget, a man whose name I mispronounce many times in the rest of this video, so sorry for that. And he was a developmental psychologist, so he did experiments on children, but in a nice way. And we're going to look at some of those experiments today. You may notice some similarities between my experience earlier in the video and these children's experiences. So let's take a look at one. Now, in the lead up to this experiment, Piaget he's given all this about how he like shows this piece of paper with like a square with like drawn points on it. He's saying this is how children see triangles, like a square with 3 points on the sides. And I'm like, Piaget, that is like, it's very hard to believe. I'm like, that surely can't be right. You must have some sort of like experimental error here. Like, how can you possibly look at a triangle and see it with 3 shapes? I feel this way whenever I look at Piaget's experiments because they're just so hard to believe. And so he shows this image, and then he shows this child who's clearly looking at a triangle, has been asked to draw it, and she's got 2 lines, and then she starts to draw what appears to me to be the 3rd line. She just like clearly draws like a square shape, and then like she's like, got to add the points. Points out the points. It's like trying to add the points. They look kind of like other squares to me, to be honest. And it's like, it's right there. Like it's right there. Can't you see how different this is? Like, what are you thinking? What do you think you're looking at? Like, how can that possibly be what you think a triangle looks like? Obviously, it's 3 years old. So, but I just think that's like, I can't even imagine what that child must be thinking and how she must see the world. It's like hard to even conceive, hard to even think your way in to those ideas that are kind of in the middle. And then in the original recording, I go on for ages about that. Let's look at another one, but I'll let the psychologist introduce this one.
We'll say it's the ocean, this blue cardboard.
Huh?
We'll say it's the ocean. You know the ocean? Have you ever seen the ocean? And in the ocean, we put some islands. There are islands.
Oh, yes.
Okay?
Yes. A big one.
A big one, yes. And on one island, we built a house. You see, it just fits on the island. It's built on the whole island, but it doesn't go off it. Now, what I'd like for you, with these blocks, you build a house, too, on that island here. On the whole island, but without going off it, And I'd like that house to have just as much room as this one here.
Okay.
Do you understand? Just as much room as in this one.
More?
Just as much. Okay? Go ahead.
I can't put any more.
Yes, that's fine.
There.
It's the same house? There's just as much room in the two houses?
Yes.
You're sure? How do you know?
Because I see.
How do you see? You can lift that one if it helps you. You can pick it up. Show me. I don't see very well. Ah, yes. I didn't mean like that.
Okay.
But show me how you see there's just as much room in the two houses.
Because I see they're just this big.
And if they're just as big, like that, there's just as much room in them?
Yeah.
You're sure?
Yes.
So this is a classic result out of Piaget's work, is that children below a certain age don't have a very good conception of volume, or perhaps no notion of volume. They just see size. You can see, is using the level of these blocks to determine whether they have the same size inside them. A few caveats, of course, they did way more experiments than this. This is just the ones they filmed, so we can assume that there is more rigor behind this than just one video. And in case you're wondering, why the kind of audio is a little odd, it's translated to English from the French, hence why all the children have French names. Now, as children get older, of course, they develop their concepts, and so we're going to look at another one now.
Do you think that there's just as much room there and there, or not?
This is Irene, by the way. I think you can probably tell she knows there's something not quite right about the situation.
No, because there it's thinner.
Aha, very good. So what would you have to do to have just as much room?
Make it bigger.
Then make it bigger.
On this side?
Hey, can you build in water?
No.
So how can you make your house bigger?
I don't know.
A minute ago, you told me there isn't just the same room in these two houses.
No.
Where is there more room?
Here.
Okay, so you have to make more room in the other house.
Yeah.
So how can you do it? I'll give you some blocks and you build some more.
On top, then?
Yes? You want to?
Yeah.
Okay, go ahead.
It's really relatable. I can really feel how she's feeling there. It's like almost exactly how I feel when somebody in the chat and I'm doing a maths problem and they point out something. I'm like, okay, I know you must be right, but I guess I have to do this, but I don't see how it makes sense.
So, you think that's okay now?
A little bit more.
A bit more?
Yeah,
go ahead.
Try a bit more, Ren. Probably a bit more. She seems to think so, this woman.
You want me to help you? I'm not very good at it, but there. You want to put some more, or do you think that's enough?
That's enough.
That's enough? There's just as much room now in the two houses?
Yes.
How do you know that? Can you tell me how you know?
No,
But you're sure that there's just as much room, or not absolutely sure?
not absolutely.
Not absolutely sure. Why do you think that there's just as much room? What makes you think that?
Because it's high enough.
Poor Irene. She's in what Piaget might call a state of disequilibrium, where her current set of ideas clearly aren't quite working. She's aware there's something wrong, but she's not yet able to apply the next level of ideas to actually make some impact on her situation and solve the problem correctly. So she goes as far as she can, and then, well, ultimately all of us have to stop at the point where it doesn't make sense to us anymore and we can't quite see where the next idea comes from. I feel, as you probably guessed, a lot of empathy for Irene in this situation. I feel this is often exactly where I am with my mathematics learning at the moment. Let's look at another child, this time a bigger leap. So Irene was about 5 and this next child is about 10. And he has made some notable progress on this task.
There.
There's just as much room in the two houses?
I'd say so.
You'd say so. Okay. How can you tell?
Well, there are 3 lines. And then I looked at the lines.
Where are there 3 lines? Explain it to me.
There. 1, 2, 3.
Okay, those big lines there. And then there
and
are 3
then
of
there
them?
I can put them.
Yes, show it on this side maybe.
There.
There. It's the same 3.
And then there's 3 lines on top, and I can put them there.
Yes. Can you show me the lines on top? Can you put them there? Those? The
Yeah.
last 3? Yeah? So the last 3 are these 3 lines?
Yeah.
Okay.
Now, this isn't really related to the story I'm trying to tell you, but it's interesting to note the different kinds of learning that Mathieu has gone on here. Piaget actually breaks down learning, particularly for children, although I think in general also into these 2 categories, figurative and operative, with operative being things you can do to things, so smash or build or stack or things like that, and then figurative to be the objects you can recognize in the world and the way you can break them down and the kind of things you can see in them, the way you can analyze things. And you can see that Mathieu here has actually made some real progress when it comes to that figurative analytical skill, and he's breaking down and placing on top of the world these abstractions, almost like little diagrams, which then enables him to make significantly more progress in the operative side of things, which is building something with the same volume. Anyway, back to Didier, who actually isn't done yet.
And then the first ones, that's to make it as high as the house?
Yeah.
Okay. And that's how you can be sure that there's just as much room in the 2 houses?
No, because there I didn't do all the sides.
Ah, so then what?
I have to put 3 more.
3 more. There. What do they represent, those 3 more? Can you show me on that one what they represent?
That one.
That side.
Yeah. And then I put 3 more.
Yes.
They represent this side.
So now you have which ones that are done?
That one, that one, that one. I only have to do that one.
Okay. Okay. That's that side?
Yes.
And it was all going so well. Didier, again, has a kind of half understanding. He understands it's something to do with size, something to do with the shape, something beyond just the same height again, but he hasn't quite got it. So what does this tell us? Well, of course, we have to go through multiple, likely, of these half ideas before we get to something which actually works. And of course, I know how to do this task, but I feel like I'd be robbing you if I didn't show you the 12-year-old Popov's successful attempt. So let's take a look at hers.
What are you counting?
I'm counting so it has the same volume.
Yes, but explain what you count each time.
There has to be 4 times 9 cubes to make that.
4 times 9 cubes, because 9 cubes, what does that represent?
Well, the surface of that.
A slice. Yes, show me the slice. All right, all the way around.
and then there have to be 4 to make the whole building.
Good. So go ahead.
And there she goes, stacking like a pro, perfect understanding of volume, just like all of the rest of us adults. This documentary is great, by the way. I'm going to link to it in the description. It's called Piaget on Piaget. There's a bunch of French with slightly dodgy subtitles, but it's really a delightful watch, as indeed many of Piaget's experiments are. You can see other examples of children doing experiments like this, or rather people experimenting on children with scenarios like this, various places on YouTube, and they're a great fun watch. So what can we take from this? What conclusions can we draw? Well, I'm going to record myself slightly riffing on a few points, so we'll see if I manage to say anything interesting. So the first thing is that these conceptions, these kind of middle ideas between not understanding and full understanding, they're interim. So when you learn them, you don't need to get too attached to them. Ultimately, when you get some new idea, probably from a problem or from some reading, you can hold it kind of lightly because you're probably going to throw it away. Doesn't mean it's not important, doesn't mean it's not useful, but you're waiting for the next thing to come along. Second is that these ideas are developed through contact with reality. And in maths, this probably means doing problems, because that's the only way you're going to surface that your current conceptions are wrong and you need to move on to better ones. In other fields, it's going to be other sorts of contact with reality. But crucially, it doesn't come through passive experience. Now, this is kind of a truism in education. You want to make it practical, you want to make it real, but it really brings home. The point of going through these experiences is so that you can destroy your current set of ideas and reconstruct new ones. So don't avoid that experience. Always be looking for your next opportunity to apply these ideas to see which ones work and which ones don't. The third, and this is one which has occurred to me, of course, in the scope of this video, is that they are accelerated by reflection. It can be very, very useful when you come across a problem that you're like, what on earth? Like, this doesn't make any sense. And then you realize that over the course of that, you're now able to do it. Something has changed in your understanding from when you couldn't do it to when you could. It's really worth reflecting on that process and trying to work out what you learned through that experience. Through that, you're going to be able to both understand perhaps where your old conception may be useful, maybe in a more narrow sense, and what the limitations on your new conception might be. If you can understand that journey, you may be better prepared for the next reconstruction you're going to go through. So that's the practical part. But I also feel kind of charmed by these ideas. Remember that child with the triangle? These ideas, while they're not maybe the best reflections of reality, they are precious. They're very special things that help us through a very difficult moment in our learning journeys and potentially in our lives as well. In those moments, they're perhaps all we have. We can't just draw the ideas out of other people's heads. We have to deal with what we've constructed and make friends with those things so that we can get through to the next thing, even as we throw away those old ideas. So they're precious, they're special, and crucially, they're also forgotten. One of the funniest things about these ideas, and the thing which originally sparked me to think about this video, is the knowledge that these interim ideas, they leave us unusually quickly, like a dream, in that you can remember it at the start and then you kind of lose it. These ideas are the same. Because we move on from them, because they no longer make sense to us at a particular point and we no longer draw on that information from our brains anymore, we very quickly forget them and we lose the ability to empathize with ourselves when we were at a lower level of understanding. This is one of the things that teachers spend all kinds of time and attention on, is trying to understand what different kinds of middle knowledge exist in the world and in the minds of learners so that we can help draw people through to the next stage. So make friends with them, love them, all that stuff. So that's that for this video. This one, I've tried to keep it a little scrappy, a little rougher, not overthinking it, not putting too much time into planning it out and editing it and making it huge, because that's why I haven't made so many videos lately. So if you're waiting for more videos, then hopefully this is me getting a bit back into the habit and practice of that. So you've probably noticed a bunch of like editing glitches and me getting different amounts of distance from the microphone and annoying myself when I'm editing. etc. So anyway, good to spend this time with you, and I'm going to finish up this video and post it because that's the whole point. Hope you have a wonderful rest of your day and week. And by the way, I stream, not the direct Tuesday after this, but I stream regularly. The whole point of the maths thing is I'm working through The Art of Computer Programming by Donald Knuth on stream. So hang out on Twitch. I'll put the link in the description. Come hang out if you would like to spend time with me, mostly struggling to get through that process, as I will be for a long time yet. All right, see you later.